This video will be about using variables. So a variable is a letter used to represent a number, usually in a situation where the number can be changing. So for example, let's say you have a cell phone plan that charges 10 cents per minute. So if we were to go and figure out a few of the values, we usually put this in a table. It's just a way to organize data. After 1 minute, you would have to only pay 10 cents. And we figure that out because 10 cents times the 1 minute is 10 cents. If we were doing 2 minutes, we'd pay 20 cents, and we figured that out by doing the 10 cents times 2 minutes, which gives us 20 cents. Could do it again for 3. 3 minutes would be 30 cents, because 10 cents times 3 minutes is 30 cents. Now these numbers are changing. The number of minutes you talk changes. So we can represent that with a variable. Most commonly we use the variable x. So this time we can't just say this is x cents. We have to do it by how we multiplied it out. This would be 0.10, so 10 cents times x, which we can write a little bit simpler as 0.1x. We don't have to write the extra 0 on the end. We don't have to write the multiply sign. If you have a number next to a letter, it's assumed that you are multiplying. So this final answer here is called an algebraic expression. An algebraic expression involves numbers and variables. The difference between an expression and an equation, which we'll learn about later on, is that we don't start out with an equal sign. We're not trying to solve for x with an expression. So we can change entire sentences into an algebraic expression. But if we're going to change entire sentences, we need to know some key words. So addition, you can use the word add. You can use the word more than. Total, increase, sum, plus, and gain. Now these are not every single word that means plus. It's just a pretty comprehensive list, but you may run across a few more. Minus, we could use subtract. Difference, decrease, less than, fewer, decline, or minus. Again, this isn't every single word that means subtraction, but it's a pretty good list. Multiplication, you can use the word times, product, per, of, twice. That means specifically times by 2, or triple. That means specifically times by 3. And divide, you could use quotient, divide, split into, half would be dividing specifically by 2. Now when we do get to work with equations, we need to know words for equals. We can use is, same as, makes, gives. And you can also use total. Notice total was also on the addition list. It can be a little ambiguous. You have to look at the context to know whether it means equal sign or plus. So for example, 12 more than x. We know more than means, looking at our list again, more than is over here at plus. So we can do 12 plus x. Now less than can be a little confusing, so we should do a less than example. 5 less than x. You actually have to do this backwards. If you did 5 minus x, that would be x less than 5, kind of reads backwards. So less than is backwards, but if it said 5 minus x, we would just do 5 and minus sign and the variable x. Sometimes they won't actually use the letter x. They will just use the word number. Let's say we have the quotient of 3 and a number. So when they say the words unnumbered, that's where we bring in our variable x. Now we could use another variable. Let's say for this one we want to use the variable n for number. So quotient means divide, so we'd have 3 divided by n. Let's do one last example. The sum of 5 and 2 times a number. This time we have multiple math operations going on. We say sum is addition. We say 2 times, that's multiply. We know a number means variable. So sum of 5, so 5 plus 2 times a number, so 2 times x. And when there's a number next to a variable, they don't usually write out the multiply sign, they would just write 5 plus 2x. It's assumed that there is a multiply sign here. So we can use writing an expression from a sentence in order to come up with an equation for a real life problem. So let's say we have, what is an expression for the total cost of a watermelon that is 75 cents a pound. So we need to come up with variables for all our important things in here. So total cost, that is an important piece of information. That's what we want to find the total amount of. So cost, we usually use C. Not necessarily, you could use T for total cost, but often they use C. Of a watermelon that is 75 cents a pound. So there's another important piece of information, a pound. So pounds, I'm going to use P, since the word pound starts with P. But a lot of the times they use LBS for pounds, so you could maybe use L for pound. I think P works a little better for us. So then we can write an expression from this. So total cost. Total cost, this time total means equals. So equals 75 cents a pound. So when it says a pound or per pound, this is multiply. So maybe add a to your multiplication list. So we have cost equals the 75 cents per pound or a pound, so times P. Again, they're going to leave the multiplication as an assumption. You know there's multiply there, even though it's not written. So the last kind of problem is finding the expression using a table. Let's say we have a table where we have hours worked and your pay. Let's say for 1 hour you make $8.25, for 2 hours $16.50, 3 hours $24.75, 4 hours $33. So we have to again decide variables. Hours worked, I'm going to use H. Pay, I'm going to use P. Again, really we could use any variables. I could say X is hours worked and Y is pay. It doesn't matter as long as we know what variables we're using. So then we need to come up with an expression. When you're using a table, then we want to see what's the difference between each of these pay values. So $8.25 to $16.50, that's $8.25 more. $16.50 to $24.75 is also $8.25, and $24.75 to $33, also $8.25. This $8.25 is how much we're making per hour. So per hour we're making $8.25, and we know per means multiply. So your total pay would be your pay rate, $8.25, times the number of hours you worked, because it's per hour. I'm not even going to write the multiply in this time, because we know we can leave it as an assumption. We know this is really $8.25 times H. So your total pay is $8.25 per hour. And that's our expression we would come up with from that sentence and from that table. So that concludes our discussion on using variables.